Hello, I'm Pushkar and I am master teacher in chemistry at Vedantu and I'm discussing KVPY 2018 S6 part 2 chemistry paper. Here is a question. For an electrochemical cell shown below, platinum H2, P is equals to 1 atm, H plus aqueous, XM, Cu2 plus 1m Cu. The potential is 0.49 volt at 298 Kelvin. The pH of solution is closest to. Four options are given. They're quite far apart 1.2, 8.3, 2.5, 3.2. So we have to see what is the pH of the solution. So the fundamental of this problem is that we can see that we have platinum and H2, which is of course at 1 atm pressure. Then we have H plus ion concentration, XM, we don't know what is the concentration, salt bridge, and Cu2 plus, and of course it is at 1 molar concentration, and Cu. So we can approach this problem like this. E cell is equals to E cathode and minus E anode. And as shown, cathode is this because cathode is always represented towards the right hand side. So that is cathode and it is in standard condition. So standard condition, if it is standard condition, the value of this is also given. So we can say that this is 0.34 volt and minus the potential of this anode. So E anode, we have to write the reduction potential of E anode. So this must be equal to 0.49. We'll approach it like this. Now what is E anode? Anode is basically the process of anode can be represented as in the reduction form twice H plus H into H2. So what is the reduction potential of anode? If we write it, the Nernst equation for this, we can write EH plus H2 is equals to E naught H plus H2. And we know that E naught of H plus H2 is 0 minus 0.0591 divided by 2 log of pressure of H2 divided by H plus concentration whole square. We can write it like this. Now pH2 is equals to 1. It's given 1 atm. So there is no need of putting it here. And this 2 can be cancelled by this. And log of 1 upon H plus is nothing but what? pH. So we can say that EH plus H2 is equals to 0 minus 0.0591 and into pH. We can take it in this form. So substituting this result in equation number 1, if we substitute this equation number 2 in equation number 1, we get 0.49 is equals to 0.34 minus and minus of 0.0591 into pH. So if you look at this result, you can quickly calculate the pH. You can quickly calculate the pH. So what will be the value of pH? Solve this and we will get the value. So let us see what will be the value. If you solve it, you will get something like this. And 0.49 minus 0.34 is equals to 0.15 is equals to 0.0591 to pH. And if you divide 0.0591 with 0.15 with this one, that is equals to nearly 0.15 divided by 0.06 nearly. So that is 15 by 6 and 15 by 6 is 3, 5 by 2, that is nearly 2.5. So what are the options? Closest option is the C option. These values you can use here, 1 Faraday, and you can find it out. You must do it before that 2.303 into 8.314 into 298 Kelvin divided by 96500, it is nearly equal to 0.0591. This value has been used here and we have taken it approximately equal to 0.06 volt. So use these equations to get there is slight correction here, 10 raised to the power 4. So I hope that you understand the problem and also understand this trick to solve this problem. It's not to take it by copybook style that can make this problem slightly lengthy. To do this shortcut, it's not shortcut, it's a conceptual way of tackling it, that E cell is equals to E cathode minus E anode. For such tricky solutions or for detailed solutions, stay tuned and enjoy the solutions. I hope that you understand. Thanks for watching.